Right, the next question is about special relativity, basically. It says, can anything move faster than light? What about a laser beam pointed to a faraway planet? What about that bright spot on that planet? Can it move faster than light? This is not a question about general relativity, but this is a famous question, actually. So let me answer that. The question is as follows. Um, First of all, can anything move faster than light? Any material, any matter, can matter move faster than light? The answer is, according to special relativity, no. We talked about the curvature of space-time and locality of measurement of speed of anything. But overall, in an inertial reference frame in special relativity, nothing, no matter, no material can move faster than light. This is a result of special relativity. And light moves at a constant speed. In vacuum, it's like c with some numerical value. You know about this. But the second part of the question is, what about an experiment like this? Let me show you by drawing a picture, because this is much easier to understand. Let's imagine that this is our planet, okay, and someone has a laser and is pointing to a very distant planet or a galaxy, whatever. Say by some, using some exaggeration, we can say this is Jupiter, for example, or even more distant object. So the brightest spot where the laser beam, contacts that far away, like Jupiter planet, would be a bright spot here at point A, say, okay? Then the question is, if we move our hand from this position to another position, let's say here, okay, very suddenly, then the light would move in this direction and it's gonna touch Jupiter or whatever that distant object is at point B. So if you make the velocity of your hand fast enough, because of this angle here, the brightest spot at point A would move with a very fast velocity to point B. So you can do this fast enough to make the speed of the brightest spot of laser beam on Jupiter faster than light. Okay, is this possible or not? Because no information can travel faster than light according to special relativity. So apparently there is a contradiction here. But the question is, in fact, very simple, much simpler than this, and you shouldn't be confused about this. Let me explain it. The answer is that no, this is not going to happen. This is not would happen even with a simple configuration. But let me back off a little bit, which is very hard doing this, the technology I have here. Okay, so back to here. Imagine that you have a laser beam, the same configuration, and you are pointing to a distant object, very distant object, far away. I call it Jupiter, but whatever. And it's steady, there is no motion between planets, etc. We are talking about a thought experiment with special relativity. So if you have enough time and you're pointing in this direction, well, there is a bright spot, A, on that object, Jupiter. Okay, so far so good. But now you decide all of a sudden to move your hand very quickly to a new position, say in this direction. And because of this angle, even if very small, because this length here is very large, astronomically large, so you expect that point B would be far away from point A. So because you're moving your hand very quickly, so you have the brightest spot on this object, Jupiter, has a very short time to move from A to B, so this velocity might be larger than the speed of light. But this is false. This is not going to happen. Why? Because even if you imagine a similar experiment with a water hose, you'll see that this is not what happens in practice. So let me explain it about light, and then we can turn back to water to have a feeling about this. Here, when you do this, why I'm doing this? I did this one time and then, okay. So you are here. You are in this position, and these are photons, okay? Moving with speed c. Vacuum, and you're touching point A. Now, when you decide to move your hand to this configuration, if we have a slow motion movie of this, what's going on is this. You go, gradually from this position to this final position, right? So when you are here, for example, the new photons that you're emitting, your pointer, your laser pointing is, radiating, would be somewhere here. But the old photons left like a second ago, they are still here. So if you look at photons, the trajectory of photons, it could be something like this. And a very short time after this, it's going to be something like this. After something like this. So when you do this quickly, this is what's going to happen. So it takes some time. When you are here, it's going to be something like this. You can imagine this. So the beam of light is not going to be a straight line. It's going to curve, not because of gravity, general relativity. No, because you're just, and it's not a curve, actually. It's like a, not zigzag, but, you can imagine it in this kind of, straight lines. Okay, when you move your hand and you take screenshots of this. And you can understand this maybe more easily by imagining that you have a water hose in your hand. Say this is a water hose instead of laser pointer, and you are soaking someone who is standing at A, standing still, no motion, and you have enough time, and you are just shooting water on that person at A, and you're soaking him. Okay, now you decide all of a sudden to move the water hose in this direction, okay, in this direction, here. You're not going to be able to soak someone else here at B immediately at no time. It's going to take some time for the beam of water to move from A to B, and that speed can be shown to be less than the speed of light. So you can do a simple calculation in special relativity to understand this. But even using a simple example, a water hose example, you can understand what's going on. So the answer is no. Using a laser beam or something like that and moving it quickly on Earth, for example, the bright spot on a distant object like Jupiter is not gonna move faster than light, and you can understand it using this example. So the answer is no.